8.3, solving right triangles. Solving right triangles. This means that they're going to give you some data about a right triangle and you have to figure out the rest. Okay, that's what they mean by solving right triangles here, okay? So let's go to example number 1. Example number 1 says, use the trigonometric ratio cosine A is equal to 0.6 to determine which angle of the triangle is A. Okay. So really we have 2 choices here, right? So if we don't get it right the first time, we're supposed to get it right the next time, right? Because either A is going to be 1 or A is going to be 2. Okay. It's definitely not this guy because this guy's 90 degrees, okay? So it's either this guy or this guy. So, but I've been given that cosine A is 0.6 and I have measurements here. I have 3.6, 4.8, and is it 6? 6, okay. All right, so let's look at this. Cosine was what? Cosine was SOHCAHTOA. So cosine is basically the what? Adjacent over the hypotenuse, right? Adjacent over the hypotenuse. So the cosine of angle 1 here, the adjacent one, the one next to it, would be this guy, 3.6 divided by the hypotenuse. Whereas cosine of angle 2, right? Again, the hypotenuse stays the same, but this would be the adjacent leg now, right? This would be the adjacent one. So I'm looking at 4.8 over 6. Okay. So this is going to be 0.6. This is going to be 0.8. So which one of these was A? Obviously, it is number 1, right? Angle number 1 is angle A. So this guy here was A. Okay, pretty simple stuff. Okay, example number 2 is fairly complicated. Okay, so pay very close attention. Example number 2, we're going to introduce a concept called inverse trigonometry. So inverse, we'll do the inverse trigonometric functions. So if I had sine, okay, let's go back to the 60, 30, 90 triangle. And what were the ratios of the legs and the hypotenuse for this? Can anybody tell me? Go ahead.
Was it for the, it's S at the bottom,
S.
and then on the other side it's 2S,
2S.
and then it's S root 3.
Correct. Okay. So basically, really, it is 1 to 2. If I divide everything by S, this is what I get, right? This is the ratio, correct? 1 to 2 to square root of 3, right? So sine of 60 degrees is going to be what? What is sine? Sine is the opposite over the hypotenuse. So the opposite of this would be this guy, right? Divided by the hypotenuse, correct? Whereas the cosine of 60 would be the adjacent over the hypotenuse. Tangent 60 would be the opposite over the adjacent. Okay. Inverse trigonometric function is denoted as such. Okay, so it takes this value here. So I'm going to put this value in here, 60 degrees. The inverse trigonometric function is the angle that gives me this value. Okay, so because this is the angle that gives me this sine value. So this is the opposite. This is the angle which gives me this value. So this is the value. They're saying what angle gives me this value. And that's the angle right here. Same thing as arc, okay, inverse sine or arc sine. Okay, inverse cosine or arc cosine of 1/2 would be 60 degrees. Arc tangent √3/1 is equal to 60 degrees. Okay? I'm not necessarily interested I mean, obviously it'd be great if you guys mastered this or become proficient at it, but really at this point, we're just kind of introducing the concept here. Know that there is a function that inverses the function that we had before, sine, cosine, and tangent. Just know that there's an inverse function there, okay? Okay, so example number 2. So let's see if we can find, let's see if you can do this on your calculator. So bring your calculator out. Now you would need a TI-84 or better or true calculator for this, I believe. I don't know if you have, if your phone one would have this. Make sure you're in degrees mode. Make sure you're not in radians, okay? Make sure you're in degrees and see if yeah, just as I expected, there is no arc sine or arc cosine. Raise your hand if you're able to come up with 60 degrees. 1, 2. I have 2 people who are able to do that. Oh, no, you got it over there? Okay, all right. Haven't got it. Anybody else? Okay, good. Try to do the same thing with sine, arc sine of 1/2. Arc sine of 1/2. Let's see what you get. Tell me what you get as an answer. You figured it out? No? Yeah, it's right up there. Yeah. So you would put 60 degrees. No, I'm sorry. Hear that? 5. And arc cosine. Well, that's you have to do second. You one on top of the other one, isn't it? Second. Okay, all right. Did everybody get 30 degrees? Anybody got 30 degrees? All right, okay, good. We're making some progress here. Okay, all right. Anybody else? Okay, raise your hand if you do not have access to a TI-84.
Wait, is it the ones that say the -1?
Yes, that's the one. Yeah. Where did you get that at? Is that a separate app?
No, this is the calculator like this is second. And it just,
Oh, there's a
Oh, I see.
second there. Okay. Nice. Very good. So on your phone, Bellin, that's Samsung, right? It's Galaxy?
yeah.
Okay. I don't know. Let's see if the iPhones have it.
This one, mine has a
Oh, I got it.
Second, yeah, if you press second on your phone, okay, if you press second, there's the arc sine, arc cosine, and arc tangent there, okay? Okay, the ones on the bottom, do not use the one on the bottom. The sine with an H or cosine with an H. Okay, that's hyperbolic sines and hyperbolic cosines. You won't use it unless you're going to become an engineer, so don't worry about that. So, okay. So we got that, we did that, so we're able to do that. Okay, so let's do example number 3. Let's move on to example number 3. So just know that if you have a value of a sine, cosine, and tangent, now you have a way or a method to try to actually find the angle itself. Okay, so now I can give you questions like this, example number 3. Right, I can say example number 3, and I have a triangle that is 7.5 and 5. And I can ask you to solve the right triangle, right? I can ask you to solve, what does that mean? I need to find the hypotenuse, because I don't have the hypotenuse, correct? I need to find the hypotenuse, and I need to find these 2 angles, right? I know this angle, it's 90 degrees, right? Okay, so what's the hypotenuse? How do I find the hypotenuse? Okay, so I'm going to have, if I call this C squared is going to be equal to 7.5 squared plus 5 squared. Therefore, C is going to be the square root of that, correct? Okay. So if I do that, what do I get? Anybody, somebody please go ahead and plug that in for me. So I'm supposed to get 9.01. So this is going to be equal to 9.01. Okay, so now I have to find the angle here. So I can use actually sine, cosine, or tangent, whichever one I want, right? Because I have all 3 of the 2 legs and the hypotenuse, right? Which one is the preferred one here? If there is a preferred one. Any guesses? Any philosophies? Any opinions here? I would choose the one that involves these 2. Anybody have a reason why that would be? If for some reason I screwed this up, right? And I punched the wrong button in my calculator, whatever, I don't know, whatever, right? Okay. There's a chance that I could have got this wrong, right? But I know these 2 are not wrong, right? So why deal with something that I had to derive rather than just use these 2 that I know for sure are good? Okay, so I know that the tangent of, we'll call this A, the tangent of A is equal to the opposite over the adjacent, 5 over 7.5, which is 2 over 3, right? So this is going to be, so if I need to find the angle A is going to be the arc, the tangent that gives me this value, right? Anybody tell me what this is on their calculator? Then what'd you get? Anybody else? Somebody who was able to do it? Raquel?
Well, I got like 33.6.
33.6?
Well, actually 33.7.
33.7, okay, 33.7. We'll just round up and say about 34 degrees. Okay, so if this is 34 degrees, what is this guy here? Huh? 60? 56. Everybody agree with that? Why is it 56 degrees? Because these 2 have to add to what? 90. What is that called? Complementary. Remember that? Way back when there was complementary versus supplementary, right? Supplementary where you add to 180. Complementary was when you add to 90, right? Okay, all right, good. Good work. Okay, so that's example number 3. Example number 4. Example number 4. Solving a right triangle in coordinate plane. The coordinates of the vertices of JKL are that, and that. Find the side lengths to the nearest hundredth and the angle measures to the nearest degree. So I have -1, 2, -1, 2, -1, -3. -1, 2. What's the last one? 3 and -3. 3, -3. So this is my triangle here. And we are trying to find what? The lengths. Okay. From here to here, what's this length? They're the same, they have the same y value, correct? So it's just counting squares from here to here, isn't it? From -1 to 3, so -1 to 3, so this must be 4 down here, right? From -1 to 3. Now here to here, I have the same x. Again, we're just counting squares from -3 to 2. So that would be 5, right? 5. Okay. So this guy would be what? Let's do the distance formula here. x2 minus x1 squared plus y2 minus y1 squared. What is this? Reeve, what is this?
4.
4 squared, right? What is this?
-5 squared.
Which is the same as 5 squared. So I'm going to get 16 plus 25. Okay. This is 90 degrees, right? This is 90 degrees. So I just need to find this guy. I just need to find one of these and I can find the other one there, right? So the tangent value, so this is square root of 41. So if this we call A, tangent A is equal to what? What is the tangent? Tangent is the opposite over the adjacent. So it's opposite over the adjacent. Opposite would be 5. Adjacent is 4. 5 over 4, which is 1.25. So how would I solve this in my calculator? I would find the arc tangent, right? The arc tangent of 1.25. I can find an angle there. If you do that, looks like I'm going to get 51 degrees. 51 degrees. So this is 51 degrees, which means that this guy here is what? 39, right? This plus this has to be 90 degrees because this is 90 degrees. 59 degrees. So we solved everything. We've got all 3 legs. We've got all 3 angles. Okay. All right. Travel applications. So let's travel. Example number 5. San Francisco's Lombard Street is known as the crookedest streets in the world. The road's 8 switchback were built in the 1920s to make the steep hill passable by cars. If the hill has a percent grade of 84%, what angle does the hill make with a horizontal line? So the grade is measured as the run over the, so it's this distance over this. So this over this is 8.84, so 84, 100, right? Okay. And I want to find this angle here. Should I calculate the hypotenuse? Or not?
You can just use tangent.
I can just use the tangent, right? I can just use tangent A is equal to the opposite over the adjacent. So it's 84 over 100 or 0.84, the 84% grade, right? So there really is no reason for me to calculate the hypotenuse here, right? So I know this guy, so the angle A, again, is going to be the arc tangent angle that gives me this value of tangent. Okay, and if I do that, it's like I get 40 degrees. Okay, any questions? Any questions? I think we're done for this section.